Professional course in English. Process technology. Equipment and systems. Unit 5. Extraction and other separation systems. In this lecture you will learn extraction, absorption, adsorption, scrubber, solvent dewaxing. Extraction. One of the most frequently encountered problems in chemical process operations is that of separating two materials from a mixture or a solution. Distillation is one way of making such a separation, and it is perhaps the most frequently used method. Another useful method is extraction. Extraction is a process for separating two materials in a mixture by introducing a third material that will dissolve one of the first two materials but not the other. Each method of separation has its own advantages and disadvantages, and several situations call for the use of liquid-liquid extraction rather than distillation or some other methods. Reasons for extraction. In many cases, it is impractical to separate two chemicals by distillation because the boiling points of materials are too close together. In such a case, it is frequently possible to find a third chemical that will dissolve one of the two chemicals. In this situation, extraction would be a better method of making the separation than distillation. Many chemicals are highly sensitive to heat and will degrade or decompose if raised to a temperature high enough for distillation. In this case extraction, which can usually be carried out at normal temperatures, would be a practical alternative. Often, one of the materials to be separated is present in very small amounts. It might be possible to recover such a material by distillation, but it is usually much easier and more economical to do so by extraction. Finally, the key requirement of any commercial process is that it be economical. In situations in which several alternative means of separating two chemicals could be used, the one that is the most economical is chosen. Because many relatively inexpensive solvents are available, and because the equipment required for an extraction operation is relatively simple, economic considerations often favor liquid-liquid extraction. Liquid-liquid extraction process. There are basically three steps in the liquid-liquid extraction process. Contact the solvent with the feed solution. Separate the raffinate from the extract. Separate the solvent and the solute. Step 3, recovery of the solvent and solute, is left to be done by some other processes such as distillation. The feed enters to the lower portion of the extraction column. The solvent is added near the top. Because of density differences, the lighter feed solution tends to rise to the top while the heavier solvent sinks to the bottom. As the two streams mix, the solvent dissolves the solute. Thus, the solute, which was originally rising with the feed solution, actually reverses its direction of flow and goes out with the solvent through the bottom of the column. This new solution, consisting of solvent and solute, is called the extract. The other chemical in the feed stream, now free of the solute, goes out the top as the raffinate. The raffinate and extract streams are not soluble in each other and will layer out. Properties of a good solvent. The solvent must be able to dissolve the solute, but it should not be a substance that will dissolve the raffinate or contaminate it. It also must be insoluble so that it will layer out. The density of the solvent should vary sufficiently from the density of the raffinate so that they can layer out by the effects of gravity. The solvent must be a substance that can be separated from the solute. It should be inexpensive and readily available, and it should not be hazardous or corrosive. Equipment. Basically, the equipment for commercial operations is designed to ensure contact between the solvent and the feed and to separate the extract from the raffinate. The simplest extraction apparatus is the single-stage batch unit. Multi-stage operation, which consist of a series of single-stage units, coupled close together. Figure 3 illustrates concurrent extraction. Figure 4 illustrates countercurrent extraction. Extraction columns. There are three main classifications of extraction columns: packed columns, tray columns, mechanical columns. Absorption. Absorption columns. An absorption column is a device used to remove selected components from a gas stream by contacting it with a gas or liquid. Figure 6 illustrates the scientific principles involved in absorption. Adsorption. Adsorption is the process in which an impurity is removed from a process stream by making it adhere to the surfaces of a solid. During the adsorption process, the mixture to be separated is passed over the fixed bed medium, adsorbent, in the primary device. At the conclusion of the cycle, the process flow is transferred to the secondary device. A stripping gas is admitted into the primary device. The stripping gas is designed to remove or separate the selected chemical from the adsorption material. At the conclusion of this cycle, the stripping gas stops as the process switches back and repeats the process. Equipment. Equipment for adsorption operation is relatively simple. It consists primarily of a tank or vessel containing a bed of adsorbent, be it ion exchange resins, molecular sieve, or whatever. In most cases the bed is fixed. Scrubber. A scrubber is a device used to remove chemicals and solids from process gases. Scrubbers are cylindrical and can be filled with packing material or left empty. As dirty gases enter the lower section of a scrubber, they begin to rise. As these dirty vapors rise, they encounter a liquid chemical wash that is being sprayed downward. As the vapors and liquid come into contact, the undesirable products entrained in the stream are removed. As the dirty materials are absorbed into the liquid medium, they fall to the bottom of the scrubber, where they are mechanically removed. Clean gases flow out of the top of the scrubber and on for further processing. Solvent dewaxing. Dewaxing is the removal of wax from lubricating oils. The wax content is critical in determining the viscosity of the lubricating oil. In cold weather, it is necessary for lubricating oil to retain its ability to flow and lubricate. Lubricating oils are classified into different grades on the basis of wax content. Paraffin wax is made up of paraffin hydrocarbons. These hydrocarbons will crystallize when the oil is cooled. The wax then forms and can be separated by the filter in the crystallizer. Figure 10 shows a typical solvent dewaxing process. The solvent dewaxing process has 3 steps. The oil is mixed with the solvent and cooled. The oil is filtered and the wax removed. The solvents are recovered and recycled. To revise the learned material, answer the questions. What is the primary purpose of the extraction process? What are the reasons for extraction? What are the properties of a good solvent? What equipment is used in extraction process? What are the 3 main types of extraction columns? What is the difference between adsorption and absorption? What is the primary purpose of a scrubber? What is the primary purpose of solvent dewaxing?